Hi, I'm Al Bowden, president of Sencore. How many times have you found that a peculiar symptom was cured after replacing a capacitor? Or have you ever wondered if a coil might be causing your circuit problem but didn't have a replacement in stock to substitute? Or have you ever found yourself trying to decide whether to change the capacitor or the inductor first, since either causes nearly the same symptom when defective? Let me assure you, you're not alone in the battle with reactive components. They can cause some of the toughest troubleshooting problems of all. That's why Sencore introduced the Zmeters back in 1979. Zmeters test inductors along with capacitors because they're usually used together. Zmeters have been among Sencore's most popular instruments. Their dynamic tests find defective capacitors and coils that other testers often miss. We thought the best way for you to fully appreciate the benefits of using a Zmeter would be to show a real-life situation. Let's look in on Fred's service bench as he gets a visit from Harry, who has a service business on the other side of town.
Morning, Fred. Good to see you again.
Hey. Hello, Harry. Good to see you, too. Hey, what brings you over to this side of town?
Well, you're one of the best technicians in the area, and I always find it helpful to compare technical notes and, trade some secrets. And, while I'm here, I don't mind rolling up my sleeves and giving you a hand if you need one, too.
Well, I hate to disappoint you, but I'm not too full of advice today. I decided to toss this old RCA television receiver up on the bench one more time to see if I could find out what the trouble was. Now, I have worked on this dog on and off for a couple of weeks, and the profit has definitely gone.
Well, you know me. I don't promise to have all the answers, but I don't mind giving it a try either. What's wrong with it?
Well, the darn thing seems to overload. It becomes unstable, and there's some sound buzz once in a while. I have changed a number of components and haven't had any luck.
Okay, Fred. Now let's take a look at it here. What is common to all of these things? Have you looked at the AGC circuits?
Well, that's what I thought, too. But there are only a few parts in the AGC circuit, and I substituted for them. Now, I also changed the AGC transistor. I'm pretty much out of ideas.
Well, gosh, Fred, that's awfully costly, soldering in these parts and taking a chance of destroying them or goofing up the PC board for testing purposes only. I seldom substitute parts anymore. I've found that I never have the exact right part to substitute. Even with close substitutions, you can easily make a mistake in a critical circuit like the AGC.
Well, I agree. I don't like substitution either, but sometimes I can't think of any other way to go.
Let's start by assuming that the new transistor is okay. Let's have a look at the AGC filter with your Sencore waveform analyzer. All right, now set the time base to read the horizontal sweep waveform and measure the sync ripple with the peak-to-peak function. Hey, look, the horizontal residual level is too high. Looks like the AGC filter, don't you think?
Sure it does, but I already changed it. And what's more, I used a brand new capacitor from my distributor.
Fred, you know that most new lytics aren't really new. These things often sit on the distributor shelf or your shelf for months or years. They age every day, they aren't used, and eventually they become defective. We've passed a new law in our shop since we got our Sencore Z-meter. Test it before you use it. Sure saves us a lot of headaches.
Harry, I agree. I test every capacitor with this handy little capacitor tester before putting them in. But it shows nearly every one I test is good. I just can't see paying the extra money for a Z-meter when this one checks capacitors too.
Fred, I don't know if you're being fair to yourself if you think this cheap little thing is making the same test as a Z-meter. They're about as different as night and day.
Well, that's a pretty bold comment, isn't it? In my book, a capacitor checker is a capacitor checker. And frankly, I found that checking capacitors is pretty much a waste of time. They're all checked good.
Well, the problem is that your tester only checks value and misses most of the bad capacitors because the value rarely changes. Now, with lytics, for example, the value remains good until they've completely dried out. But they cause circuit problems a long time before that happens.
Well, that sounds right. Can you tell me more?
Even better, let me show you. I've got a Sencore Z-meter in my van. Let me run out and grab it, and we'll have another look at that circuit. Then maybe you'll see why that cheap tester is really doing you more harm than good.
Okay, Harry. Hey, back so soon?
Yep, I carry my Z-meter where I can grab it in a hurry. You'll rarely find me without it on the bench or in the field. Okay, let's unsolder one lead from that filter you installed and have a look. Now, the capacitor is marked 22 microfarads at 35 volts. We'll just enter these values into the keyboard so the AutoZ converts all of the tests to good-bad results. Now here, I'll let you make the test. You hook up the leads. Now just press the value button and read.
Well, the value is 21.8 microfarads. Now that's what my meter said too. It's well within tolerance, so it's good, right? I mean, that's right where I was before.
Now we'll slow down. The value is good, but we're not done testing the capacitor yet. Of course, with your value-only tester, you only have one test, so that's as far as you could go. But now the Z-meter has 3 more tests, so we don't know if it's good or bad yet. All we know for sure is that its value is okay.
Yeah, but won't it take 3 times as long to make those other tests?
No, it might take another minute. But how many hours have you already put into this set since you've installed that capacitor?
Oh, I'd hate to guess. Maybe 6 or 8 off and on.
And if the Z-meter proves that the capacitor is bad, the extra minute of testing could have been 8 hours of profitable billing. So that cap tester just increased in cost by 8 hours worth of your good billing time.
Gosh, I never thought of it that way.
By the way, I'm not sure how much range your unit has, but Z-meters will read all the way from 1 picofarad values used in RF circuits all the way to 200,000 microfarads for the biggest filters. And this deluxe model I'm carrying even reads to 20 farads to check those new capacitors used as battery backups in VCR and the like.
Well, that's a lot more range than my unit. What are we going to test next?
Well, as I said, electrolytics seldom go out of value tolerance. But that special electrolyte solution inside a lytic can cause a lot of other problems. Leakage is the most common. Let's check it next.
Well, why should we use the Z-meter? Why don't we just check the leakage with an O-meter?
Well, here's where the Z-meter really separates the good ones from the bad ones. You see, even though leakage is a current path in parallel with the capacitor plates, it doesn't act like a resistor. It's more like a Zener diode. It looks fine when tested at the low voltage used by an ohmmeter, but conducts when you apply the circuit voltage.
Yeah, I think I've seen that. I remember a replacement that blew its top off when I've applied voltage, even though my ohmmeter showed they had no resistance. Boy, there was little bits of paper everywhere.
Yeah, I guess we've all picked up electrolytic paper out of our hair at one time or another. You know, that's why a Z-meter lets you dynamically test with up to 1,000 volts applied. It will simulate the circuit conditions to confirm the capacitor doesn't break down. But its limited current won't blow up a leaky capacitor. In fact, you can use the Z-meter to reform most leaky caps before you put them into the circuit so they won't blow up.
Hey, I like that idea. And my wife has threatened to make me wear a baseball cap when working on power supplies. So what do I have to do to make this test?
Let's look at the operating voltage rating on the side of this electrolytic. It says 35 volts. Now, it depends on which Z-meter you're using. If you have one of the automatic models, like this LC-102, all the comparisons are made automatically. If you have one of the lower cost units, you first look up the value and the voltage rating on a pull chart to find out how much leakage is allowed. Now you see, the chart shows that this capacitor should show less than 300 microamps.
Okay, so I press the button, right? There. Now the first reading was way over 300 microamps. It's bad, right?
Not so fast. You have to give the capacitor a chance to charge first. Now just hold the button in for a few seconds. Now you see how the readings drop? There the reading dropped below 300 and the good indicator came on. The problem isn't because of leakage, but there are 2 more tests to make. Let's check dielectric absorption next.
Dielectric absorption? What the heck is that, a disease? I never heard of that.
Well, Fred, you might call it a disease of aluminum electrolytic capacitors. Sencore discovered that many lytics were giving trouble because of dielectric absorption, and technicians couldn't test for it at all. So the test was added to the Z-meter.
Well, what is dielectric absorption?
Fred, filter capacitors are supposed to charge and discharge between cycles of pulsating DC, right?
Well, sure.
But problems in the dielectric can prevent full discharge. Some people call this soakage or battery effect. As a general rule, if a cap charges to 100% and discharge at 90% or more, they're usable. But if they discharge less than 85% of their energy, they're getting to the point where filtering is affected and they are considered defective.
Okay, I've got it. But how the heck do you test for that?
Well, not as difficult as you think, Fred. On the basic Z-meters, you check value, then leakage, and then recheck value a second time. Now, the value should not have dropped by more than 15% and hopefully not below 10%.
Oh, I get it. If the electrolytic has dielectric absorption, the value will be affected because it retains some of the charge.
Right. But it's even easier on the auto Z-meter we have right here. Just press and hold the dielectric absorption button until the automatic circuits show a percentage in the digital display. Go ahead and press the button.
Okay, it shows 10%. Well, now, if 15% is bad, that seems high in this critical circuit.
Well, you might be right. Critical circuits should have better capacitors than those used in power supplies. 10% is on the edge. But let's make the last test to make sure there isn't some other problem.
You mean that there is another test? I didn't know that anything else could go wrong with a capacitor.
Well, sometimes, Fred, capacitors have internal resistance buildup due to poor welding or crimping. This resistance is inside the capacitor in series with the capacity. I've even seen it on some brand new capacitors.
Harry, you can't get your ohm meter connected to the other side of the resistor. How can you check it?
A Sencore Tech Tape explained how their engineers solved this tricky problem. Now, the Z-meter uses a special square wave test which lets the resistance be measured separately from the capacitive reactance from outside the capacitor. This dynamic test is calibrated directly in ohms, so you know how much actual resistance is present inside the capacitor.
Hey, that's great, Harry. Hey, let me push the ESR button and find out. Hey, look at this. It reads 600 ohms. Is that too much?
Yeah, it sure is too much. It's just like putting a 600 ohm resistor in series with the electrolytic in this AGC circuit. This capacitor will probably work fine in a 60 hertz power supply, but it won't filter the 15 kilohertz signal used by the AGC circuits.
How do I know how much is normal? Do I have to calculate or memorize values?
No, the Z-meter pull chart has a guide, just like the one we use to find normal leakage. You look up value and voltage rating to find the normal level. Or with the Auto-Z, you simply check for a good or bad indicator, which is based on the chart's value.
Well, I'll be darned. This replacement capacitor has both dielectric absorption and equivalent series resistance. Do you suppose that's what was wrong with the capacitor I removed from the circuit, too?
Who knows? Let's hook it up and have a look. There you are. All right. Hey, look here, Fred. The old one had the right value, but had too much leakage. So, you ended up replacing one bad capacitor with another one with different problems.
Well, yes, but I thought that the new capacitor was good. Since the symptoms were nearly the same, I thought that something else must be the problem.
Now do you see how costly part substitution is?
You're right. Hey, let's find a good capacitor and see if it fixes the problem. Here's another one that I bought this month. Let's test it and find out.
Okay. Hook her up. Its value is good. Leakage looks fine. Dielectric absorption is okay. And ESR is in limits. It's a good one.
Okay, well, I'll just tack it in place to find out. There. Now, that should do it. Let's turn the TV on. You are absolutely right, Harry. That got that dog off my bench.
You mean that Z-meter was right, don't you, Fred? You know, I would have been guessing just like you were without it. The Z-meter, you know, has become a standard of the industry. Now, when are you going to break down and buy one?
Harry, you've got my attention. Tell me just a bit more. You say the value never changes. Well, why should I have a value check at all then?
Didn't say never. I said seldom. Electrolytics are unlikely to change in value, but other types do more often. The problems in electrolytics are most often dielectric absorption, then leakage, and third ESR. But ceramic capacitors often change in value. Some change as much as 15%. Some ceramics will also have leakage. Some film types develop dielectric absorption. So you need all four checks to find any bad capacitor.
What you are saying is that different type capacitors need different tests, but you need all four Z-meter tests to prevent making a mistake. Harry, I appreciate all this capacitor talk, but I remember that two-way radio I was working on when you were here last. It turned out to have a bad coil. You found it in minutes with that same Z-meter. How did you do that again?
Remember how you told me you had already checked every single component except the coils? Now, you suspected one was causing the problem but had nothing to check them with. Now, you told me that you didn't have any replacements in stock and didn't want to wait the week or so it would take to special order them in order to substitute them into the circuit one at a time.
Yes, that's right. And each one was a different type. So I couldn't just order one and move it from spot to spot on the circuit board until I had effectively substituted them all.
Well, Fred, we just used my Z-meter to check each coil you thought might be causing the trouble.
Right. I'm not sure I remember all the tests we needed to perform. Could you run through the Z-meter inductor test for me?
Well, okay, but only if you spring for the coffee.
Well, you're on. We'll buzz down to the cafe after we're through here.
All right. Oh, now the Z-meter has two inductor tests. The first automatically reads the inductance value from 1 microhenry to 10 henries automatically, with no interpretation. The second checks for shorted turns.
Are there only two things that can go wrong in an inductor?
Well, Fred, there are really 4 things that go wrong with coils: opens, shorts, value change, and shorted turns. Now, the most common of these is shorted turns because the windings are right next to each other.
Well, it seems that the value test would find opens and shorts too. But what about shorted turns? Do they affect value too?
Well, usually not by enough to give a conclusive test. That's why the Z-meter has a patented ringing test.
It must be pretty sensitive to find even a single shorted turn. Is it really that good?
Oh, yeah, and it's easy to prove, too. Here, hand me that coil and that little stub of solder sitting over there, and I'll show you how the test works.
Well, why do you need the solder? I don't have a circuit to solder it into.
Well, you'll see in a minute. First, let me show you how the Z-meter responds with a good coil. Here, connect the 2 leads to the coil.
Okay, it's connected. Now what?
First, let's check its value. We'll just press the value button, and all right, now tell me what you read.
Well, it says 50.9 microhenries.
Okay, now that's all there is to the value test. If you want, you can program the percent tolerance into the AutoZ, and it will give good, bad results as well.
That's really handy. I hate calculating percentages, and if I do them in my head, there's a good chance of messing them up.
That's right.
But how about that shorted turn test?
Well, just push the ringing test button and read the display. Now, the AutoZ is actually going through several different impedance matching values, looking for the best match. If the number in the window is bigger than 10, the coil is good, and that's all there is to it.
I see. Well, the reading shows 12, so it's good. What did you mean when you said that the AutoZ was going through several values?
Well, the microprocessor in the AutoZ replaces the manually operated impedance matching switch found on the smaller Z meters. Now, this is a 6-position switch, which you rotate while holding the ringing test button. You use the position which gives the largest number. If the number is bigger than 10, the coil is good.
Do all 6 positions have to show a number bigger than 10?
No, the rule is 1 or more. Some coils might show numbers over 10 in all the positions. Others will only show a number over 10 in one position. In either case, the coil is good.
Okay. Now, what are we going to do with the solder?
Well, we're going to use it to simulate a shorted turn. Here, now just wrap it around the coil and twist the ends together to complete the circuit. There you go. All right. Good.
Okay. But there's no electrical connection. Don't you want me to scrape some of the insulation off the wire?
No, now, see, that's the beauty of the Z-meter test. The closed loop forms a short which reflects to the main winding. Now, if you have a coil with several windings and only one is shorted, all of the rest will read bad. You only need to test one winding, even on something as complicated as a flyback transformer with 5 or more secondary windings.
Okay. Now I've got the solder in place. Now what?
All right. Now, just press and hold the ringing test button again.
Wow. The number only reads 4. And we haven't even shorted the windings. We've only placed the short next to the coil. Do I have to use this solder trick every time?
Oh, no. That's only to demonstrate how a shorted turn would affect the readings. Now, if you have a bad coil, the shorted turn is actually inside the coil.
Okay, the ringing test found the short. But wouldn't a value test have done as well?
Well, let's take a look. Now, remember that we saw a reading of 51 before. Now, check the value again with the simulated shorted turn still in place.
Wow. The value barely changed. A value check wouldn't have done me much good on this one, would it? But what about an ohm meter? Couldn't I use it to find shorts?
Oh, sure you can if the coil has a dead short from end to end. But how many times does that actually happen?
Sure, a dead short is one thing. But wouldn't the ohm meter tell me about a shorted turn, too?
What do you think? Now consider a coil with 1,000 turns of wire. Now, how much do you think that the resistance will change if only one turn is shorted?
I see what you mean. But this ringing test will find that a single shorted turn, right?
You got it.
Is that how you found that bad coil in that radio last time?
Right again. You could have made money on that two-way radio if you had this test at your fingertips.
Well, coils and transformers are often tough to unhook and hook up again. It sure would be nice if one could test these in circuit.
You know, Fred, the Z-meter tests inductors in circuit with great reliability. It will never lie to you by calling a bad coil good because of surrounding components. In those few cases where external components load the coil and cause a low value or low ringing test in the circuit, you will know right away when you double check the coil out of the circuit. But most good coils show good while fully connected, proving they are good without even warming up your soldering iron.
I'm beginning to see why you rely on the Z-meter so much. Is there anything else that this meter will do?
As a matter of fact, there are several things. Now, I don't know about you, but one of the biggest problems that I have is finding the distance to a short or an open in a transmission line.
Don't tell me that the Z-meter will do this.
It sure will, and very simply. Transmission lines are made up of series inductance and parallel capacitance. You use the capacitance per foot when locating opens and the inductance per foot when locating shorts. Now divide your Z-meter reading by the appropriate value to find the distance to the problem.
Oh, that feature would have saved me a lot of work when I was servicing the MATV system at the Star Motel last week. I finally found where a carpenter had driven a nail through the cable behind the wall. I had to tear down part of the wall to find the short.
Yeah, Fred, you know, the Z-meter would have pinpointed that problem to within a couple of feet. You know, it can save digging buried cable, pulling cables through ceilings, and a lot of other work.
Is there more?
Well, the Z-meter works equally well to measure resistances that are too large to measure with your ohm meter, such as those high resistances in the TV high voltage section, or high resistance leakage that only shows up when voltage is present in switches or PC board insulation. These are usually called high pot tests. If there is leakage, you will find it.
Could there be any more tests that the Z-meter let me do?
Well, now here's the frosting on the cake, Fred. Most of us don't have a way to test SCRs and triacs. But if you simply use this SCR-250 SCR and triac test accessory and mount it on top of the Z-meter and follow these simple instructions while pushing the Z-meter leakage button, it will check these hard-to-test components dynamically for actual turn-on or turn-off capabilities. It will find the defective components every time. Now, most of us don't own a separate SCR and triac tester and welcome these added tests.
Well, Harry, I have to tell you, I can see why you said earlier that I shouldn't compare your Z-meter to my cheapy capacity tester. The little one only tells me that every capacitor I test is good, and then leaves it up to me to find the bad parts by changing one part after another. But when you showed me that I had actually installed the defective capacitor into the AGC circuit, even though I had checked it, you really opened my eyes.
Now, Fred, I wouldn't feel right giving away my trade secrets to competition on my side of town. After all, the Z-meter helps me stay profitable, when many of them are barely making a go of it. But since you're way over here on the other side of town, I think it's only right. After all, you've helped me through a couple of tough dogs in the past, so I feel I owe you some.
Yeah, don't worry, Harry. I won't spill your little secret to your competition. But I do plan to call Sencore this afternoon to get my Z-meter on order. Then I'll be as good as you.
Fred, knowing your technical background, I know you'll be even better than me.
I don't know if I'll ever be better than you, Harry.
Oh, sure you will. Now, where's that two-way radio you were showing?
Z-meters are guaranteed to find defective components that all other testers miss. They help you troubleshoot better. Z-meters come in different models, depending on your budget and testing needs. The basic models have manual tests. The LC-102 Auto Z-meter adds automation to make your work easier. Let's see how the basic models compare to the deluxe model LC-102. First, capacitor value. All Z-meters are 100% auto-ranged. Just press the value button and read the display. The biggest difference is the way you calculate percentages. The basic models give the reading and leave the interpretation up to you. The Auto Z includes a percentage calculator. Just enter the plus and minus percentage. The Auto Z then converts the measurement to a good or bad reading. In addition, the LC-102 measures to a full 20 farads compared to 200,000 microfarads for other Z-meters. Second, capacitor leakage. Depending on the model, Z-meters let you apply up to 600 or 1,000 volts to the capacitor. The Auto Z eliminates the need to look up leakage on a chart. The LC-102 microprocessor has these charts in memory. The display shows good if the leakage drops below the allowable level. Third, dielectric absorption. Basic Zmeters show this condition with a three-step test. You test value, then leakage, and then value again. A good capacitor shows little difference between the two value readings. A bad one shows large differences. The LC-102 test provides a direct readout. The percentage shown agrees closely with the laboratory test for dielectric absorption, but requires much less time. The test is completely automatic. Just hold down the button and read the percentage. Fourth, ESR. Just like leakage, the allowable amount of equivalent series resistance depends on the capacitor's type, value, and voltage rating. You use charts to find the acceptable value with conventional Zmeters. The LC-102 has the charts in memory, so ESR readings are converted directly to good-bad values. The two inductor tests show similar differences. First, inductor value. All Zmeters are 100% auto-ranged. The difference is that the Auto Z converts the readings to good-bad results, just like capacitor value. Plus, the Auto Z measures values that are 10 times smaller than other Zmeters. Read values as small as 0.1 microhenries. Finally, the inductor ringer. Sencore introduced and patented this test in 1975. Since then, the over 50,000 testers in operation have proven its reliability over and over for finding bad inductors. The difference between Zmeters is the degree of automation. With regular Zmeters, you watch the digital readout for the highest reading while rotating the impedance matching switch through its 6 positions. If one or more of the positions show a number larger than 10, the coil is good. The Auto Z meter automatically matches test impedances. Just select the inductor type and press the inductor ringer button. If the number in the window is larger than 10, you get a good indicator. If it's less than 10, you get a bad indicator. That's all there is to it. In addition, the Auto Z meter is battery operated and has Sencore's special computer interface port. Connect to a computer for 100% automatic testing. Use either the IEEE 488 General Purpose Interface Bus or RS-232 communications. Only Sencore lets you add either computer interface at any time by simply plugging in the appropriate accessory to the interface connector.
When you choose Sencore, you are choosing test equipment from the leader in American-made analyzing equipment for over 40 years. Every Sencore product is innovatively designed with your time in mind. Each is supported by a team of specialists dedicated to helping you use your Sencore instruments more effectively. Before you look at any other brand of test equipment, consider first the 25 exclusive services that back each Sencore product. Sencore's value-added services fall into 5 categories. They are innovative product design, after-the-sale support, fast, reliable service, rock-solid guarantees, and finally, versatile purchasing options. Let's take a look at each.
When you choose Sencore, you're choosing innovative products designed to make your testing easier and more reliable. Sencore instruments include exclusive tests, guaranteed to save you hours per day. But even with innovative tests, Sencore is easy to use. Sencore designers know it costs you dearly to fiddle with a knob, connect an extra test lead, or interpret inconclusive results. Sencore products are so logical, You usually operate them without instructions. When you want to know more about a test, Sencore gives you easy-to-learn manuals and simplified operating guides. You don't even worry about errors. Sencore instruments have maximum overload protection. Sencore instruments keep on working when most others are damaged. Best of all, Sencore is manufactured and supported from America's heartland. Every employee strives to produce innovative products of the highest quality.
When you choose Sencore, you get after-the-sales support second to none in the industry. Just dial 1-800-SENCORE anytime you have a question about our products or services. Your call will be answered by a specialist in our customer call center. Amy, could you tell me what happens when a customer calls into our center?
We can answer most questions. Calls are rarely transferred to another person or department. If you need specific information, we inform your sales engineer. He has a degree in electronics so that he gives correct answers. Sencore's application engineers are available for questions about using an instrument. Application engineers also bring technical schools to your area. These technical workshops explain how to use Sencore instruments effectively. Between workshops, technical information comes to your mailbox through the industry-exclusive Sencore News. Technical articles explain testing methods and update you on the latest Sencore instruments. Exclusive Tech Tip technical bulletins and Tech Tape video programs provide even more specific information and training.
The third way that Sencore differs from all their competition is with our factory direct service. When you send any product for service, it is repaired and on its way back to you within 72 hours, in or out of warranty. Besides being repaired, it is also renovated with the latest circuit updates added automatically under the Sencore 100% made-right lifetime guarantee. Each unit is recalibrated to manufacturing tolerances referenced to Sencore's Traceable Standards Lab. While your unit is in for service, you can even rent a loaner for zero downtime servicing. If you order replacement parts, Sencore guarantees fast delivery. If we cannot ship a part to you within 48 hours, you get the part absolutely free of charge. Advice on servicing your unit is also toll-free call away. Dial 1-800-SENCORE to talk directly with a service technician.
The fourth main point, Sencore puts all of this in writing with 5 rock-solid guarantees. First, every new instrument has Sencore's 30-day proof of performance guarantee to let you know you've made the right choice. If the new instrument doesn't do everything you think it should, return it for a full refund, including shipping. Second, in the unlikely event of problems, each unit has a full 1-year product warranty. But it's only fair to tell you that less than 2% of all instruments shipped each year need service. Third, Sencore's 5-year rust-proof warranty covers all metal parts. If any part rusts, it will be replaced at no charge.
Fourth, every instrument from Sencore is covered by the industry's only made-right lifetime guarantee. This buyer's protection plan corrects any manufacturing defects for as long as you own the instrument. Finally, the service department gives you a brand new 90-day guarantee every time your unit comes here for service.
The fifth major point, Sencore tailor-makes purchasing plans to fit your budget. If you purchase with cash, you get free freight and an extra discount. Sencore's exclusive pay-as-you-grow program lets you increase productivity now while your instruments pay for themselves through increased productivity. Or you can bill accessories or instruments to your Visa or MasterCard for instant orders. Sencore also offers a liberal lease plan. Finally, if you want to evaluate a unit before you buy, check into Sencore's 10-day Try Before You Buy program. Put the unit through its paces to prove it does everything you want. No matter how you order, you get fast delivery. Over 95% of all orders are shipped right from our warehouse the day after the paperwork arrives.
These 25 value-added services apply to every Sencore product. You get the finest test equipment, plus a company dedicated to making you more successful. For more than 40 years now, Sencore instruments have been innovatively designed with your time in mind.